Hello CNC people. Today we're going to talk about adjusting the wheel sets for SmartBench. The wheel sets are the bearings for each of the axes, X, Y and Z, and how to do that. It's something that you only really need to do if you notice that there's any slop in any of the axes. And we'll talk about the theory, and then we'll go ahead and we'll actually break down the machine and show you an example of how to do that adjustment. Let's do it. Okay, so let's start by talking about the theory of the design behind each one of the wheels, and they're all the same. So what we've got here is the wheel itself, and you can see that it comprises of two bearings, some tires, and then a spacer on the back. And the spacer allows the bolt to compress down onto the wheel, but you'll notice that the hole in the middle of the spacer is eccentric. It's not in the middle. And the reason for that is it allows us then to be able to move the wheel about the axis of the bolt into a position which applies either more or less preload into its aluminium axis. To explain that, I've got an example wheel set here which has got 4 wheels. This is actually from the y-axis, and an example rail which is the aluminium profile which the wheels run in. So you can see from this angle that the wheels load into the profile, which is the same shape as, or same section as the wheel, and as I load in they contact different sides of the profile. The wheels themselves are oriented so that you've got these 2 wheels here point to contact on the left side of the profile as shown, and then the other 2 wheels contact on the other side of the profile as shown. So I'll load those again slowly. You can see first one's touching the left, second one's touching the right, third one's touching the left, fourth one's touching the right. And they engage on the chamfers of the profile. So coming back to the theory of the eccentric spacer holding each wheel, I can now show you, if we have a look at the wheels end on, and I slacken off this wheel, I can adjust that spacer and move the spacer around such that the wheel is able to move closer or further away. I'm just using this aluminium profile as a visual reference so that you can see that gap changing as I rotate the spacer. It's effectively camming the wheel into the side of the aluminium extrusion profile that it's running on. So knowing that, we then need to make sure that each one of the wheels has a certain amount of what we refer to as preload into the side of the aluminium extrusion that it's supposed to be contacting. And it's a bit of a balance. You want a situation where you do have preload, because that means that there's no slop in the wheel set system, but you don't want too much, otherwise you're unable to load those wheels into the extrusion in the first place. So getting that preload right is a case of putting the assemblies together, and as you load those sub-assemblies into each other, you can quite easily see what situation each wheel is in, and we'll go through that process next. So we've got this machine here. We'll quickly break that down, and I can show you me loading the y-axis onto the bench, and I'll tell you what I'm looking out for as we do it. Okay, so I've taken the lower beam off, and I'm just going to show you what I'm looking for in the wheel sets. So down here you can see the 2 wheel plates. We've got the left and right, and the first thing I'm going to just have a quick look at is, are any of these axis bolts loose? They all look good, and so that's a good start. There was no play in this axis before I took it off, so I don't expect to see anything here, but to check, I'm now going to show you me reloading it back into the rails, and I'll show you what I'm looking for next. Okay, so I'm lifting it up, just balancing it on my knee there, so it gives me a chance to get my hands underneath the beam. And as I load the beam into the rail, the first wheel that engages here on the left side, that's gone in fine. And now paying really good close attention to the opposite wheel on the other side. And I can see both of those rotating, which means that they've both got enough preload on them to cause that rotation. And it feels like a little bit of a pop, almost as if they're sprung. And that's a good sign. That says to me that there is a little bit of preload on there. I can load it easily. They're both engaging into the side of the rail. And really I'm going to repeat that process for every wheel as it loads. So now I've got my first wheels in, I'm now going to push the second wheels in, and I'm going to watch as the first one engages, that's spinning. So does the second one spin? Yes it does, and I can feel again a little bit of a pop there as it engages into the rail. That's good. Next up, a bit easier now, we're into the third wheels. Yeah, there's that pop, feels good. As we come on to the fourth, the pinions will start to engage into the rack, so let's get past that. I can feel the pinions are engaged now, and now we're just finally looking for those fourth wheels. Are they both rotating together? Yes, they are, yeah. So that to me says that's, that's a good wheel set. And to be honest with you, that's exactly what I was expecting. The lower beam was, felt rigid before I took it off. So no surprises here. But of course, I'm not really teaching you anything here because this is a system that's working. So let me take it apart. I'll slacken off a couple of wheels to simulate a condition where one of those bolts has come loose. And I'll go through the process as to how we can reset that wheel. Okay, so I've just loosened off some of the wheels to give, I guess, a simulation of what the beam would be like if it was loose. And so I'm just going to go through what I would look for and how I would correct those wheel settings. The first thing I would do is, once I'd identified that there were loose wheels, I would slacken off the pinions and the motors engagement with the racks, because I want to focus on getting these wheels spot on in the rails. I wouldn't want the pinions competing with their engagement as well. So first thing we do, take an Allen key, slacken off the top bolts for each one, and then a number 10 spanner just to undo our bolt heads on the other side of the motor. And you can see now that I can rotate the motor completely out of the way. Just do that on this side as well. So with those out of the way, I'm going to repeat exactly what we did when we loaded the first time. I'm going to offer the beam up, watch each wheel as it gets loaded into the rail, and then use that process to identify whether the preload on each wheel is correct. So, up we go. So first wheel's going in. Yeah, they're both rolling okay, and I can feel a little bit of a pop, so that's fine. Offering up the second wheels now, and I didn't feel any pop there. The left wheel is rotating, but clearly the wheel on the right is not rotating, which is a very good indicator that there isn't enough preload on that second wheel. So I'll remember that, and we'll just offer up the third set. Yeah, feeling a bit more of a pop there, and they're both rotating okay. And then finally, yeah, I can feel the pop on the fourth wheels as well. So I now know that really I just need to focus on that second set. So we'll pull the beam out again and now just have a look at these wheels. So I can see from these wheels that the eccentric part of the wheels isn't very well engaged on this wheel here, and it isn't much on this wheel either. So to start with, I'm going to try putting about a 50% engagement of preload into the rail. And I can very easily move the spacer cam around just with another tool at the bottom. Don't necessarily need a spanner for this job. And you don't need to go crazy on the amount of torque for the bolts. Just the way that the arrangement of the spacer is, doesn't need that much torque to lock it in place. Also, we're going into aluminium plate here, so you don't want to overload the torque either in fear of stripping out the threads. These have already been thread locked with blue grade Loctite, which is a manual grade Loctite, which offers quite a lot of retention in the actual holding torque on the bolt. So again, you don't need to go crazy on that torque. So I'm just going to put another 50% on this wheel as well, as a starting point. And you can see it, that's fairly easy to see, where you can see what I sometimes refer to as the fat side of the wheel is halfway up the axis of the bolt. So with those being set, I'll offer up the beam again and we'll have a look at those wheels again. So first wheel's going in, second wheel's going in, and I can see immediately that they're both engaging, which is a really good sign. And it doesn't take much to push them in, but there's definite pop there. Same on wheels 3, and yeah, 4's got a bit of pop as well. So that's great. And actually, I know that I messed around with the second wheel, so I'm not that surprised. Now, just one important note there. What I did was, when I adjusted this wheel from the, if you will, the 0% condition to the 50% preload condition, I made sure that I did exactly the same on the other side. So I did symmetrical adjustment. And if you think about it, that is important, because in theory, it's better to adjust everything symmetrically so that the mid plane of the lower beam just stays in the middle. I could only adjust one side, but that would skew the beam over to one side. And whilst there are clearances in the pinions and the racks and the profiles, they are designed around being on a mid plane. So if you adjust one wheel, just make sure that you've got the setting, it's mirror opposite on the other side. So let's put it in, and the next step when it's in will just be to reset the condition of the pinions back into the racks, because we loosened those at the start. Now we've got the lower beam on, we just need to check the pinions are engaged with the racks. So the motors are arranged such that they just simply pivot around the top bolt, and then they're locked off with a hex nut on the inside here, which we'll reach in a second. The first thing to do is to just lift the motor into engagement with the rack so that the pinion is touching the teeth. And we're not after a huge amount of contact pressure here, it's just enough to really just to get a good contact. You don't want to be applying a massive load though, because that would just be pushing the wheel sets further down. So I'm going to lift up and literally with a few fingers pressure just maintain the position of the motor before locking off that top bolt. Now you'll find that that pressure on its own is enough to maintain the position of the motor. So I can let go and now get my spanner into the recess between the motor plate and the rail just to lock off that final hex nut. Now you do not need to apply a lot of load to this hex nut. It's actually going through the threaded section of the aluminium faceplate on the motor. So if you apply excess torque, it is possible to strip out the threads on the motor plate, and it really doesn't need much. A lot of the load is already set pretty well by that top bolt, and this final hex nut is literally just adding the final bit of locking off torque. So we've done one side, and then we'll just repeat the process and do the second side. And as a final check, we just want to move that lower axis backwards and forwards and just make sure that we haven't missed anything out. You should feel a bit of resistance there. That's normal. We've got the rolling resistance on the wheels. We've also, because we've engaged the pinions and the motors are coupled together, You'll find that as you move the lower beam backwards and forwards, every motor is a generator as well, so you're actually generating electrical current, which is, getting dissipated throughout the circuit. So it's normal to get a bit of rolling resistance on that. It might feel a bit sticky, but what we're after here is just checking, is that lower beam rigid against the upper beam? This feels good, so I'm going to call that done. So I hope that's helped explain how the wheel sets work in SmartBench. While we're on this topic, let's rebuild the bench. We'll put the X beam back together again, and then we'll put the Z head on. And I can show you what I look for in the wheels on the bottom of the carriage, which holds the Z head, which make up the X axis. So we'll just put the machine back together again, and I'll point out what I look for there too. So here's our Z head, and again, this was fine. This was rigid before I took it off the axis, so there aren't any problems with this. But I am going to load it up and just tell you what I'm checking for. So again, we've got exactly the same arrangement. We've got 3 wheels on each side, and they engage with our rails on the end of the extrusions, on the end of the beam. And as I load in the Z axis, I'm going to be looking out for each wheel engaging in the rail as it gets loaded. And again, I'm going to be looking out for that kind of preload pop, and that the wheels are all rotating, which tell me that the wheels are all in the right place. So we just load our X-axis and our Z head in there, and as the first wheels engage, I can see them spinning, and then that little pop which tells me that the preload is right, and then second set, both rotating there, and the racks are then engaging at that point, and then finally we've got the final set, and they're just nice and snug up against the rails there. And really, a check for this is very easy to do with the Z head, is to get the Z head on there, and then just apply some pressure on the back and the front on the plate. And am I seeing any play there? Seeing any knocking? No, that with some light pressure, that's fine. That feels sound, and I can tell that the movement of the carriage and the rails is good there. So I'm not going to adjust anything on that. That's absolutely fine. So I really hope that all these things that I'm looking out for better inform you as to what to do if you end up with a loose axis, and how to correct it, and a bit of the theory behind how all of this works. Alright, thanks a lot, and I'll see you in the next video. Thanks, bye bye.